Hello again. In this video we're going to take a look at a new product from QHY. Now many of you will have heard of QHY because they make the QHY 8s and the QHY 9s and 10s and 12s even for deep sky imaging, and they do have quite a good reputation in that field. What they haven't done much with previously though is cameras for planetary and lunar and solar imaging, sort of something to take over from what most people use for their imaging, which is the webcam. You know, there's not a lot of options to progress any further than the webcam if that's sort of, you know, the area that you want to go into, and hopefully that's about to change. So first of all, let's have a look at this camera and look at the build quality. Right, so this is the camera itself. It's actually called the IMG132E. The case is made of a cast aluminium, and it's actually fairly heavy if you sort of compare that to its size. Not overly heavy though, it just sort of adds to the overall feel of the camera. Just looking at the front there, you can tell that it's quite well engineered, and you know, as far as build quality, I'm definitely very happy with it. It just seems like a nice piece of kit, and it even feels like it's going to perform. On the outside we've got a standard USB 2 fit in there. There is an LED in the side of the case there that lights up when the camera's in use. Now the fitting on the front for your nose piece or to fit to your telescope is a different standard than you may be used to. It's actually called a C mount. Now, not to be confused with a T mount. The C mount is still a photographic standard, and the adapters look something like this. It's actually something that's most commonly used in security cameras and that sort of thing. Now, this is a standard C mount adapter. My actual preference, if I was sort of buying now, would be to go for what they call a low profile C adapter, which means whereas this is sort of 40mm long or so, a low profile one is 20mm, sometimes 15mm. The reason for that is that I'd like at some point to be able to use a 1.25 focal reducer with the camera, just to give me a little bit more sort of variation on what I can do with it. The camera itself, I would also recommend that you fit a self-adhesive cable tie to the camera at some point. In fact, I recommend that with a lot of photographic equipment. You know, they're easily available on eBay and everything, and all you do is when you connect your USB connector to a camera like so, double the cable back and clip it into that cable clip. What that does is it stops any strain now from being put on your connection to your camera, and it's just a good tip there for overall imaging in general. If it's something that you don't do, then I would seriously consider doing that. And the reason why I've just explained that is because obviously you can see that clip on there. I don't want you thinking that that's part of the camera. It isn't. I added that at a later point. Now the chip in this is a 1/3 inch chip, so it's quite a lot bigger than a webcam chip. The resolutions available on this are 1280 by 1024 and also 640 by 480. Now I found that I'm using the 640 by 480 quite a bit more than the 1280, which is it's a big image size, and there are some sort of pros and cons between the two, which we'll go into further. But with regards to build quality, as I say, it just feels a proper solid piece of kit, and you know, it just is reassuring to just feel it. So let's just have a look at the performance and what it's capable of. Right, so as you can see, I've now fitted the nose piece to the camera and also fitted a filter. Now, filters for this sort of camera are a very personal thing. You need UV-IR cut, but my own personal preference, to be honest, is for barred neodymium. I just find that they just give me that little bit more contrast and tone in my images. You know, like I say, it's a personal thing, and it's just a type of filter that I feel comfortable with. Now also, you do want to fit a filter onto these sort of cameras anyway, and to webcams, because number one, it sorts out the UV-IR balance, but the second reason is that it creates a sealed unit. It protects your CCD that's inside there, your imaging chip, from getting dust on it and everything. So it's just a good idea to have a filter on there anyway. Now, what's the first thing you're going to notice about this camera if you come to use it? Well, it's fast. In fact, it's lightning fast. Now, okay, there's speeds that get quoted on manufacturers' websites and everything, you know, and you can take those with a pinch of salt, because 9 times out of 10 a piece of equipment is tested with a lens fitted onto it in a well-lit factory, and, you know, well, yeah, that's what we're hitting with it. I've actually hit 63 frames per second with this camera pointing at the moon. In fairly decent conditions, which I'll go into later about conditions and performance and results. On average, you're going to be hitting 53 frames per second with this camera on the moon and on planets such as Jupiter. Now, what does that mean to you? Well, with a webcam, if you've previously been using a webcam on Luna and on Jupiter, the most you're going to be wanting to get is 10 frames per second. The reason being that a webcam usually is USB 1, you get compression artifacts, and you just have to slow everything down so that, you know, everything can keep up. This camera doesn't suffer from any of that. You know, you can go to these lightning speeds, and what it also does, because of that speed, is it gives you a bigger imaging window. For instance, say we're imaging Jupiter. Now, Jupiter has a very fast spin rate. The planet actually rotates at quite a high rate. Now, the optimum for imaging Jupiter is approximately 90 seconds before you start to get what they call rotational artifacts, which is blurring from the actual rotation of that planet. So with a webcam, like I say, 90 seconds, you're going to be talking maybe 1,000, maybe 1,200 frames. With this thing going at full whack, at 53 frames per second, you're going to be hitting massive frame rates, you know, sort of 4,500 and higher. Although you will hit a limitation, and that limitation is in Windows, because Windows usually won't allow you to make an AVI of anything larger than 2 gig. And yes, my AVIs are 2 gig when I'm sort of, you know, taking a range with this camera. You can get around that because you can save as TIFFs, you can save as bitmaps, you can also learn with the camera. It does what they call debayering, and it also does RAW. Now, a RAW image and a debayering image, what's the difference between those? Well, basically a colour camera has what they call a matrix in the front of it, and put very simply, what that does is this. Let's imagine that you're taking a colour image, and that colour image in effect is a lot of different coloured Lego bricks hitting that sensor. And to debayer it, the camera then puts those different coloured Lego bricks in order and builds your colour image up. So what it's doing in effect is it's taking a little bit of your process away from actually focusing just on imaging, because it also has to debayer that image and put the colours in order. If you're taking a raw format, it doesn't. What it does then is it almost takes an image of your pile of Lego bricks and knows exactly where they're going to go. Then it sticks them off to one side and just concentrates on the imaging. So later, at a later point when you come to processing, you have to do what they call a debayer. So in effect, you're doing it on your computer when you come to the processing, which means it takes it away from your sort of taking some resources away when you're doing your actual imaging. Now, debayering and stuff, it might be something that you've heard of, and raw mode when you've got your web camera. This does both, so it'll learn with you. If you want to learn about debayering, which if you become more advanced and eventually you go on to sort of deep space imaging, then those sort of things are things that you're going to need to know. You can learn them with this camera because it does both, and you know, sort of teach yourself as you work your way along and progress further up the ladder. On a costing point of view, you know, a decent deep sky imaging camera is going to cost you in excess of £1,000, and this isn't going to cost you anywhere near that. Obviously, it's more limited in its use, but it's almost an in-between sort of camera. And back onto the file sizes again. Why are they so big, those file sizes? Well, the thing is that this is a 16-bit camera. It's not 8-bit like a webcam. What that means is that you will get a lot more points between a pure white and a pure black, so you get a much better sort of range of shades and a range of colours, and just your overall images, they just will look crisper and everything. Now, little point there is that I've had this camera for a couple of months and I haven't honestly had the chance to do it justice with regards imaging, because anybody who lives in the UK or sort of watches the weather in general anyway will know that for the last few months we've had horrendous weather in the UK. We've had 100-mile-an-hour winds, we've had clouds, you know, sort of even on a less windy day the gusts have been hitting 45 miles an hour. So the images that I will show you later suffer from that, and I will point that out. And that's what we're going to do next, is we're going to have a look at some images and we'll also just analyse them. Right, I know this is the section that most people have been waiting for, and you want to see some results from this camera. Now, I will point out yet again that over the last few months we've had some of the most horrendous weather in the UK. You know, we've had up to 100-mile-an-hour winds, and when the winds sort of died down, it's been gusting at 40 miles an hour, which means conditions haven't been brilliant. But I've just really wanted to get this full review basically done because I've had the camera for so long, to be honest. So, you know, I just thought it was a bit unfair to QHY not to show any results from it. So please take that into consideration, and I will point out a few things as we work through. Now, first of all, what I will show you is a couple of images taken with a webcam. Now, firstly, I'm going to show you my best ever Jupiter taken with a webcam, which is this one. As you can see, there's plenty of detail in there. It's picked everything up nicely. This was taken with an SPC 900 webcam and my 200p telescope with a ×3 Barlow in it. And as you can see, I've just about managed to pick up a moon there. With a wider aperture telescope, you tend to find sometimes you get lucky and get a moon, sometimes they just don't pick up. But overall, even though I say it myself, that's quite a good Jupiter, that, and it's taken with the maximum number of frames, which is probably about 1200 frames. You know, the majority of those stacked. This was taken in really good conditions, and as I said, that's the best Jupiter that I've ever managed. Next, I'm going to show you the best moon close-up that I've ever managed, which is this one. Again, taken with the same configuration as the Jupiter, which was the Skywatcher 200p with a ×3 Barlow fitted to it. And again, I just got lucky. The conditions were brilliant, and you know, just everything worked out well. And like I say, it's the best that I've ever done in close-up on the moon. Now, my processing isn't brilliant. I'm not going to sing the praises of my processing at all. Most of the time I just get lucky. So this was, you know, it's just outstanding for me. I'm really happy with it. But as I said, it's my best ever. Right, so on to a Jupiter taken with this new camera. Well, the first thing that you'll notice is this is a very poor Jupiter. But that was taken without any Barlow on whatsoever, which is an advantage of this chip in this new camera. You just won't need a Barlow as much. You know, normally without a Barlow on a 200p, your Jupiter's going to be quite a bit smaller than that. And as you can see, it's easily picked out 2 moons there, even at, you know, such a small size that it is. That's one of the things that you'll notice about this camera, as I explained before, you get a much wider range, so pulling moons in as well as your planet is going to be really easy. Now, the overall sharpness of this isn't great. In fact, it's quite bad, to be honest. This is, you know, it's just not great at all, and that's because this is probably only maybe 200 frames stacked, just purely and simply due to the wind buffeting the scope about and everything. You know, with a 200p, even sort of a small wind, it just bounces the scope about, and the scene hasn't been perfect, and we've had cloud and everything, so it's, you know, just to say the conditions have been so bad, it's actually not a bad image really. Next, let's just have a look at one that's a little bit bigger. That would be this one. Again, this is only actually 300 frames stacked. As you can see at this slightly bigger size, this is actually with a ×2 Barlow fitted. The moon, again, you pull it in easily. It's just easy to get the moons with a wide range on this camera. Now, although this is a bad photograph, and it's again, like I said, it's only about 300 frames stacked, so there's quite a bit of noise in there. But what is noticeable is, again, with the range, you can see the colours that are in this southern band here. There's just a lot more colour range there. You'll pick out a lot more colour. Obviously you can see that we've got a fair amount of detail there in these paler bands, which, as I said, for the small amount of frames used in that and the really poor weather conditions, I think you can see that the camera itself is showing a hell of a lot of promise. So let's just move on to some lunar shots now. Okay, this is one close-up that I did of the moon with the new camera. As you can see, it's not particularly sharp. It looks as if it's slightly out of focus. It's actually not. Again, this was taken in up to 30 and 40 mile/hour gusts, and I just had to basically grab what I could do. So there's not a great deal of frames stacked there. and also the ones that are just not of a great quality because of all the movement. But again, it shows a lot of promise. You can see a lot of range in there, and a lot of detail has been picked up, a lot of this finer detail that you just know that a webcam wouldn't pick up. And if we're going close up, you can see sort of these little paler ranges and these tiny little craterlets that are just a slight trace on there. Obviously with the much better conditions, then you know it's going to come in even better. So let's just move on and show you another one. This one was taken in obviously slightly better conditions, and I got more frames stacked, but again less than ideal. And again, you can see there's quite a lot of detail in there. This is probably comparable with the one that I showed you previously, my best ever webcam shot, with regards sharpness and detail. But again, this was taken in really poor conditions, so it shows that on a regular basis I'm able to sort of hit standards very, very close to the best I've ever done with this camera. So the potential is definitely there, that in good conditions I just know that I'm going to do a lot better with it. Here we go with another one. This one's slightly more wide field, and you can see again the ranges in the colours and everything. Now this is slightly overexposed, especially on this top end here, but you can see that all these tonal ranges and the contrast are there. It just picks up every little detail. And let's move to another one. There we go. Now this was taken with no barlowing. Again, that's the camera straight into the 200p. So as you can see, the actual zoom ratio is quite high. You know, and which is one of the reasons why I would like to use a focal reducer with it. Again, not perfectly sharp, but again, it's the weather that we've had in the UK. But again, it just shows the potential of this camera. Let's move that one over and have a look at this one. Now this is actually one of the 1280 by 1024 images. As you can see, it's a much better quality, but just it's been conditions, as I said. But we've got quite a lot of sort of detail in there, and texture. It just tends to show texture a lot more. And if we look at that in its true size, you can see that it's quite a big image. Obviously it needed cropping a little bit. There are some overlaying lines there, and that again is caused by the wind. You know, it's the frames stacking and overlaying, and there's just quite a bit of overlap with them because of the weather. But again, if you look in these craters, you can see the sort of detail in there. You know, the whole images just have texture. And finally we have this one, and this one again is at 640 by 480. As you can see, it's just picked up lots of detail and lots of tone. You know, I'm really happy with that sort of aspect of this camera. And as I said, these images have been sort of a little bit noisy and could be better. But you know, if you live in the UK, you'll perfectly understand, because you'll know full well what the conditions have been like over the last couple of months. It's just been horrendous. So overall, the camera shows a hell of a lot of potential, and it's something that I'm really going to explore even further. And it's, you know, watch this space, because I will start pushing it a little bit harder when the weather improves, and I will be publishing the photographs. So next, let's just move on to the software. Right, this is the software that you would most commonly use with this camera, and it's by QHY, and it's called Easy Planetary. Now I will say that previously QHY have been criticised for lack of support for the software, both in programs and in drivers, and hopefully that's been addressed now, and we'll show you something about that a little bit later. But firstly, once we've launched the software, as you can see, we've got quite a large preview window, and then we've got the control panel down the left hand side, or the information panel if you like, and the menu items across the top. So the first thing we want to do is to choose our camera, which is this one, and we'll go into 1280 mode for this one. There we go. Now this picture at the moment is actually some DVDs on a shelf in my living room, and as you can see, it's, you know, it's quite sharp and clear. So too much so in effect, but this is actually a lot dimmer than what you would be using in real life with, you know, the moon or Jupiter. They're actually brighter images than some DVDs on a shelf in my living room, to be honest. So hence we've got the gain and the shutter speed at the moment right up at full, which would be unnecessary. They'll be actually almost all the way to the bottom in real world use. As you can see, the histogram there is sort of all over the place, and we'll go into that in a couple of moments. Once we've selected our camera, we then click on File and click on Record Options, and we'll get this other window. Now this window gives us our setup for what it is that we basically want to do. So a recording format, be it AVI, bitmap or TIFF. As you can see, FITs are greyed out at the moment. Obviously we've got the settings for which folder we want to record into. You can put suffixes in there, so if you want to you can use a suffix, and if you're imaging the moon, then you can write moon in there and it'll put that suffix in front of your images. How many frames you want to record for each sort of run. We've got some easy push buttons there, but also we've got the slider which goes all the way to unlimited. Now you can slide that with your mouse, and then you can sort of finally adjust it with the arrow keys on your keyboard. So once we've done that, let's just have a look over at the camera setup settings, and you can see here that we can click between raw, mono, and then there's some other settings that you may not understand. These are actually just different settings for whatever sort of Bayer matrix or D-Bayer matrix you've got in your camera, which for this camera is a BG. Now it's really easy to set up, so it's not like it's complicated, because if you choose the wrong one, your colours just won't look right. As you can see there, there's way too much of certain colours. Now if we go to raw mode, you see the image goes in black and white in a mono. It's actually not a mono image. This is what we call a Bayer image, and you can see that it's got sort of a checkerboard finish to it, which is it's just the way that the data's held, and Bayered images look like that. It's actually a colour image that we need to sort the colours out, and like we said earlier, put the Lego bricks into order at a later point. So that's why it looks in black and white, but it's actually not. Now if we go to the file menu, we can see that FIT is now an available option, because FITS is a Bayered imaging system that's most commonly used in astronomy. So let's just go back over to colour, like so, and have a look at these other controls. Well, white balance, we do have a couple of buttons for setting up an automatic white balance, which means if we click, it will balance up the colours, quite well. It does quite a good job of it. If you've got a more difficult subject, such as Jupiter, that's only a small object in the middle of the screen, sometimes you may be better using the spot white balance. It actually just concentrates on a smaller area of the screen for setting the white balancing up. Now you can also do it manually, which is quite easy. All we do is, let's just drop these gains and everything down a little bit. I know, look at that, everything's becoming a lot better now. If we drop these down, like so, you can see the histogram. Now we're also still burning out. This software is quite intuitive. It's telling us that it's still too bright really for imaging. So let's just drop everything down, and there we go, like so, and you can see the histogram here. Now the idea behind the histogram is that we try and get everything to overlap and superimpose, because it's actually splitting the three colours up, the red, the green and the blue. So we're trying to just get them to superimpose over the top of each other. That's actually quite difficult in my situation, because it's the colour temperature of the lighting that's actually lighting the DVDs up that's causing it to struggle a little bit there, and that's why even the balance, the automatic balance, just isn't playing very nicely with it. So what we would do is, you get used to what it is that you see on your preview screen as to whether it'll make a good image. Obviously if you've used a webcam, you know this, that you sort of drop down until you get into a situation that it's going to come out and look right. The gain, again, we tweak between the two, but obviously always try and keep your gain as low as possible to try and get as much quality and as little noise in your image as you can. And this is a really good sort of option in this software. The green, see, we're still in the green there, so we will get an half decent image from it. I found that I like to just tweak it up that little bit and just get it so that it's just touching into the yellows, like so. Now also what the software does is, at the bottom here you will see two different FPS ratings. The first one is the disk write FPS and the second is the download FPS. Now what that is one is what the camera is actually grabbing the frames at, and the other one is what it's writing to disk at. And I found that these usually stick to being about the same, so this is where you will see your 53 or your 63 frames per second. Obviously we are also at the minute in 1280 by 1024, which means because it's a bigger file format, it's also going to take your frames at a smaller rate, because in effect, put simply again, you can't fit big pictures down a USB cable as quickly as you can small pictures. So let's just drop to 640 by 480 and look at what the difference is. At the moment we've got a download rate of 17 frames per second, 16 frames per second. So let's just drop to 640 by 480 like so, and all of a sudden we're now at 53 frames per second. So you can see it makes, you know, quite a large difference that. Now if you do change resolution, I would again set your white balance. You may find that they do alter a little bit, you know, as you change resolutions. And like I said, there's other little features within the software, you know, that you can learn, but that's the basics of it. It really is that simple. Simply point your camera at your image, set your resolution, set where you want to record to, do your gain and your shutter speed just like you would do with a webcam, set up your colour balance, and then just start to record and practice really, and you know, eventually you'll get there. That's it for the software. Next, let's just take a look at QHY's website, and also we'll show you the distribution network for this camera should you want one. Right, this is the QHY website, and as you can see we've got the normal sort of links across the top, but each product is also listed by type. So you know, whichever camera that you've got, if we look at the IMG series, it gives us some details about our particular camera. Now if we go back again and click on forum, you can see that QHY have got a quite active forum here. Mr. Q himself, who is the owner of QHY, has a regular presence in there. He's, you know, in there quite a bit. But also you can post any questions regarding drivers, use of the camera, software problems. You can post pictures and say, you know, what's wrong with this, and people will answer it, either Mr. Q himself or, you know, any other users of similar cameras or software. So the support mechanism is all there for you, and I'm actually, you know, quite pleased with the fact that the owner of the company is there on a regular basis. Now if you want to buy one of these cameras, if you go to the QHY site and click order, it will tell you who the main distributors are in your country for QHY products. If you're in the UK agent for QHY is Modern Astronomy. Now the cameras may not at this moment in time be listed in the product, but if you contact Modern Astronomy, they will give you feedback on that and availability, because it is an absolutely brand new product. So in conclusion, what can we say about the IMG132E? Well, the build quality is absolutely without question. It's a fantastically built piece of kit. What may surprise a lot of people is that the sensor in this is actually CMOS, it's not CCD. Now that's one in the eye for the people that said that CMOS can't perform with regards to astrophotography. It's actually a next generation CMOS Exmor chip that's in this camera, and it does perform very, very well. Did it perform for me? Well, yeah, taking into consideration the weather conditions, which were absolutely horrendous, I think it's done a fantastic job. And it's a market that is not very well catered for with regards to sort of solar and lunar and planetary imaging. And there's definitely a gap in the market for this sort of product, and I do believe that this is it. It's certainly the next stage up from a webcam. If that's the area that you want to go into, you know, then seriously consider it. I will say, with regards to pricing and availability, if you contact Modern Astronomy in the UK asking about these, or just, you know, make reference to this video, I do know that this camera is going to be launched in the UK with a special introductory price because of it being a market that QHY are breaking into. And that's about it for this one. So once again, thanks for watching.